Good afternoon. Welcome to EduSet Network. Friend, today we are going to discuss hydrological cycle. Hydrological cycle means the movement of water or water from land to sea or air. The general meaning of this we can withdraw. We'll try to understand this thing in respect to the climate change, what we're witnessing nowadays over the years. Deforestation and other factor have contributed to the change of climate, and we are facing a number of problems. We'll try to understand this topic, hydrological cycle, and for discussion on this very topic, we have in studio Dr. R.V. Singh, Senior Academician. He is presently head of the Department of Geography in Delhi School of Economics, and he has a lot of experience in the climate, in the area of climate change, and known name in the climate change and the atmosphere. And he is also a vice president of International Geographical Union and is a member of INSA, renowned institution of in the country. So I think his knowledge and experience and practical exposure to this area will help us to understand this topic and give insight to understand the hydrological cycle. So on your behalf, I welcome him for EduSet. Welcome, sir.
Thank you, Amrenderji. Good afternoon, viewers. Today we are going to understand hydrological cycle. As Amrenderji mentioned, hydrological cycle means the movement of water between atmosphere, hydrosphere, lithosphere, including the sea, ocean. We'll also try to understand the human activity influencing hydrological cycle. In the era of climate change, we are also will try to understand the linkages between climate change and hydrological cycle. So, first I would like to define hydrological cycle. I quote, hydrological cycle describes the storage and movement of water between the biosphere, atmosphere, lithosphere, and the hydrosphere. So, biospheric aspects of hydrological cycle, that is a very, very important component in present context. Forest, several type of agricultural activity, they also influence and impact on the hydrological cycle, and they are also impacted by hydrological system. The total amounts of water on the earth and its atmosphere does not change, but the earth water is always in movement between ocean, rivers, clouds, rain, all of which contain water, are a frequent state of change, and the motion of rain and flowing rivers transfer water in a never-ending cycle. So the whole circulation, or maybe also one can say the conservation of earth water as it circulates from the land to the atmosphere and back again, is called the hydrological cycle, or in nutshell we can also call the water cycle. Through this diagram, I would like to take the various processes. I would like to take in upper part, you can see the space and space related activities, and that is most important aspects. I would like to quote here the solar energy. Solar energy is an important source of the hydrological cycle. Then we have the atmosphere, that layer where we have various type of the processes, clouds, precipitation, the various type of the pollution, emission, absorption, these are the different processes. Then due to the rapid growth of transport development, we will have lot of release of pollutants from the vehicles. Then also in this zone, atmospheric zone, I would like to use the word cryosphere, including the existence of snow and the ice. As you know, at present we are dealing with the melting of glaciers due to the climate change, and such melting of glacier can influence the hydrological cycle downstream. Then third important, the part you can see here, like oceanic processes, different type of the currents, the evapotranspiration, various type of the land surface, processes. When I use the word the land surface processes, means also the forest or the vegetation and variety of other activity. Water is the most widespread substance to be found in the natural environment, and it is the source of all life on earth. So the sustaining life depends on the availability of water resources. Water covers 70% of the earth's surface, but it is difficult to comprehend the total amount of water when we only see a small portion of it. The distribution of water throughout the earth is not uniform. Some places have far more rainfall than the other. So we have a diversity of rainfall. Within India also you can see the rainfall decreases from east to west. Eastern part or the northeast region receive the highest rainfall, even more than 10,000 millimeter in some places. Water exists in three states: liquid, solid and invisible vapor. It forms the ocean, seas, lakes, river and the underground waters found in the top layers of the earth crust and soil cover. It exists, in a solid state it exists as ice and snow cover in polar and alpine regions. A certain amount of water is contained in the air as water vapor, water droplets and ice crystals, as well as in the biosphere. Huge amounts of water are also bound up in the composition of the different minerals of the earth crust and core. Through this diagram, I would like to discuss with you the interactive components of hydrological cycle. I would like to tell you that you can see the left corner, the solar radiation and the climatic variability and the change is a very important component of this. Atmospheric composition also influences the whole hydrological cycle, the clouds, then you can see the temperature, rainfall pattern, that includes also the atmospheric processes, including the evaporation, evapotranspiration. Then if you come on the earth surface or lithospheric system, then we have a different type of the cycles, biogeochemical cycles, the various ice sheets, the carbon cycle, nitrogen cycle, phosphorus cycle. Most important aspects in this whole interactive component: land use and land cover change. So land cover is a natural aspects of the earth surface like a forest, the water bodies and other things. Then land use denotes the cultural aspects of the landscape, of the earth surface. It includes agriculture and various channels of human activity, starting from horticulture, tourism development, various type of the transport and industrial development, road development. It influences also the runoff pattern in the whole system. So these all components are interacting with each other. So one can't see in isolation, but we have to see in a more holistic way. The sun heat provides energy to evaporate water from the earth's surface, as we have seen earlier, from ocean, from lakes, etc. Plant also lose water to the air. This is called transpiration. The water vapor eventually condenses, forming tiny droplets in clouds. When the clouds meet cool air over land, precipitation like rain, sleet or snow is triggered and water returns to the land, also including the sea. Some of the precipitation soaks into the grounds. Some of the underground water is trapped between rock or clay layers. This is also called the groundwater. In the present context, the groundwater is becoming a very important aspect of the hydrological cycle because of human activity. Groundwater aquifers are various aquifers are very severely stressed by different type of the anthropogenic activity in the form of waste deposition. But most of the water flow downhill as runoff, maybe above the ground or underground, eventually, returning to the sea as a slightly salty water. So this, whole broadly you can say these are the important sub-processes of hydrological cycle. Now through this diagram, it is very important to see the more detailed aspects of the water cycle. This is the whole atmospheric processes. You see the volcanic eruption, ice and snow cover. It is a part of the atmospheric processes. Then we have from ocean, we have the evaporation, and then the water goes to the air. Then we have formation of and also from the evaporation from the sea surface, coastal region, or even from the lithosphere, from the landscapic system. And so we have the condensation process. Then after the condensation, we have the precipitation. Precipitation, and here also I would like to bring before you the role of snow and glaciers. So a snow melt runoff, used to bring also the water to the rivers and the water bodies, and increase and decrease of water availability depends upon also the snow melt runoff. Few portion infiltrate in groundwater. Through the groundwater flow, it also reaches again going to the ocean, and So in whole earth surface, we have variety of factors responsible, you know, like a stream water, then directly precipitation on the fresh water. So the water availability depends on the rainfall, the groundwater, and then also the surface water. Then, you know, in between also we have a process of what it is called the surface runoff. Surface runoff also depends on the availability of vegetation, availability of forest cover, you know, urbanization. Role of urbanization also cannot be underestimated in this the whole process. When we have more urbanization, the runoff decreases. When we have the natural area also, when we have the more urbanization, the runoff increases. But when we have the natural area, we have, you know, decrease of runoff, and water through the percolation goes to the groundwater aquifer and again coming to the ocean. I would like to now move and discuss the different stages of hydrological cycle. This includes evapotranspiration, transport of water, condensation, precipitation, interception, infiltration, and runoff. I would like to discuss these all phenomena, you know, one by one. You can see here in this diagram that how the sun helps in evaporating the water from the sea, from the surface water within the lithosphere, from the rivers, from the lakes, from different water bodies. So the solar energy is a most important, you know, the source of energy, the constant source of energy coming not only to earth surface but also to the sea surface. Even sea surface temperature, you know, surface temperature, you know, decides and can be a very important indicator even for observing the climate change. The sea surface also temperature denotes the what is happening on the earth surface. So the water cycle is a very important aspects on the incorporating the various interactive elements between biosphere, hydrosphere, lithosphere, and atmosphere. It is very important also to see the different type of the water cycle, more detail, you know, the water cycle. You see this through this diagram, one can get that how the functioning of the groundwater, then upper part, the cloud cover, you know, it is a synthesis of the evaporation and evapotranspiration coming from sea or the ocean, and then the river and the water bodies, also from the vegetation. The size of vegetation, distribution of vegetation also influences the component of hydrological cycle. But you know, the whole movement, you know, includes the processes, you know, operating on lithosphere, the sea or the hydrosphere, and the various atmospheric processes also, you know, like the temperature pattern, because water vapor also, you know, depends on the temperature. the heat coming from the solar energy. The size of topography also, decides, control the runoff pattern, sedimentation of rivers. And so that is why, sometime now at present you see in hilly area, majority of land belongs to the common, it may be considered as a common land. People used to get the free grazing land, and so we have the more erosion, more landslides, and the more debris deposition in the rivers and water bodies, and so that is why sedimentation process is also the very, very important. Through seepage also, through percolation, water coming to the groundwater. And at present, the government or the many other agencies very much interested to recharge the water, water harvesting technology is being promoted for, collecting rainwater so that we can do the ground recharge. And, in many places we achieved that. You might be knowing that in Rajasthan, like Johars, how the water ponds, they try to create the variety of water ponds on the slopey area of Arauli, and they are able to contain the rainwater, and through this they are not only able to recharge the water, but the many rivers, downstream rivers and water bodies became perennial due to this recharge process. So the water harvesting through johars or collection of the water, these are the very, very important aspects of the hydrological cycle. Sometimes people are constructing dams, constructing reservoirs also, so we try to interfere into the hydrological cycle. So these are the largely the human interference in the hydrological cycle. Hydrological cycle, I would like to also emphasize here that under the global program, what it is called the International Geosphere Biosphere Program, the study of global change, the one sub-program was BHAC, Biospheric Biospheric Aspects of Hydrological Cycle, BAHC. And this BAHC, biospheric aspects of hydrological cycle, they try to see the linkages between the water and the vegetation, water and the variety of, the forest and other related things. Various processes are being analyzed, understood, in the era of even impending climate change. I can say few places we are getting the real climate change, few places we are getting the impending the climate change. I would like to take the most important process. It is known as evapotranspiration. Water is transferred from the surface to the atmosphere through evaporation, and evaporation from the sea, from the water rivers and water bodies. The process by which water changes from a liquid to a gas. Transpiration is the process, the one sub-process of evapotranspiration, by which water leaves the body of a living plant and reaches the atmosphere as water vapor. The water is taken up by the plant root system and escape through the leaves. The sun's heat provides energy to evaporate water from the earth's surface. Land, lakes, rivers, ocean send up a steady stream of water vapor, and plant also lose water to the air through the process of transpiration. Approximately, very broadly speaking, I can tell that 80% of the all evaporation is from the ocean. So the ocean form an important part of hydrological cycle, and it is also ocean is a sink and source of the carbon, carbon activity. So one can see a close relationship between the various biogeochemical cycles and then the climate change system. These are all also nutrient cycles. Largely our livelihood, our life depends on this. And remaining 20% coming from the inland water and the vegetation. So the ocean, forest, and inland water. Inland water includes river, lakes, various water bodies, ponds. These are maybe the very small, but it has a larger implications, global implication I can say, and more in the regional implications, through these hydrological processes. Second important process, where the ocean was the most important, then I would like to take here condensation and precipitation. And this condensation and precipitation, the process is a part of the big, larger atmospheric processes. This transported water vapor eventually condenses, forming tiny droplets in clouds. The primary mechanism for transporting water from the atmosphere to the surface of the earth is the precipitation. So, the largely you can see here in this, the atmosphere is the most important. In the evapotranspiration, first stage we try to understand the role of ocean and the oceanic processes, and any anomaly at a ocean level can influence our hydrological cycle, while here atmospheric processes, because transporting water to the atmosphere and again coming through condensation and precipitation to the surface of the earth, and that is precipitation. When the cloud meet cool air near the land, precipitation in the form of rain, sleet or snow is triggered, and the water returns to the land again, or maybe sea also you can say. A proportion of atmospheric precipitation again evaporates. So this whole process is a very complex process, and this complex process passes through a variety of activity and the processes, sub-processes operating at ocean scale and the atmospheric scale. Now I would like to take through this diagram. It is very easy to understand this. The whole third important part is a interception process. You see this, the how precipitation coming on the canopy of the tree, then canopy interception, and then we also get some evaporation of the water. So this the whole process, and then through fall stem fall, then canopy interception loss. These are the important component of the interception. The first process is gross rainfall, and this can be measured in open. You can see this, the how canopy interception and evaporation taking place from the forest or the vegetation, different type of the vegetation. Again, types of vegetation also decide the type of the pattern of interception, and the other process, subsequent processes. Through fall means through vegetative canopy and dripping out. So the vegetation and tree, different type of trees play a very important role in this process. Then we have a stream flow running down on trunks and stems, and you can see through this diagram how the water is coming, a stream flow to the earth surface, the through fall and stream flow. Then we have also the interception, between the vegetation underneath of the big tree, and then the last process is canopy interception loss, like the water evaporated from the canopy directly also going to the atmosphere, again evaporation. Through this here model, you can see this, the interception by the forest canopy, how can be defined, different type of like a canopy interception, gross precipitation, through fall precipitation that passes through the vegetative canopy, or as drip from the vegetation, a stream flow, water that flow down to streams, and then we get the net precipitation. In this process, we get net precipitation in millimeter, then the gross precipitation measured by the rain gauge, and then we get like a interception loss. Infiltration is another important the process operating on the earth surface. So the first stage we saw the role of the ocean, second stage we saw the role of the atmosphere. Now here we see the role of the lithosphere, role of the particularly the earth surface. You can see earth surface includes the mountain, includes the highlands, plateau, plain areas, also the inland river. Some of the precipitation soaks into the ground, and this is the main source of the formation of the water found in land, through the land, on land, and going to rivers, lakes, groundwaters, and the glaciers. So the precipitation directly going on the lakes, rivers, the groundwater, and then glaciers. Some of the underground water is trapped between rock or clay layers, and so that is why the underground situation, geological structure also decide infiltration pattern. The type of the soil, type of the rock decide about the rate of infiltration. I would like to here highlight also that we have some of the species, help in more infiltration of water. You might remember controversy coming through the eucalyptus plantation, because eucalyptus is not a natural species of India, and because eucalyptus help in infiltration of the more water and goes groundwater aquifers. So for marshy area this may be considered is a very good, very appropriate, but for dry areas eucalyptus plantation is considered not a more very appropriate plantation a process. Some of the underground water is trapped between rock or clay layers. This is called groundwater. Water that infiltrates the soil flow downward until it encounters impermeable rock and then travels laterally. The location where water moves laterally are called aquifers. So even the potential groundwater for water supply, we try to see the role of these aquifers. Sometime where we have the big and large aquifers, we can use that water during the off season, during the dry season. And country like India, we have the almost 68% area may be considered as a dry areas, rain-fed area. The such type of aquifer can play very important for using the underground water for irrigation purpose or even for other drinking water purpose. Groundwater, returns to the surface through these aquifers, which empty into lakes, rivers, and the oceans. Under special circumstances, groundwater can even flow upward in like artesian wells. Flow of groundwater is much slower than runoff, with speeds usually measured in centimeters per day, meters per year, or even centimeters per year. You can see here this infiltration, the process in the groundwater, different type of the percolation, droplets coming to the aquifer through various, the water courses, some going through the runoff and then going to the groundwater aquifer. So this model shows the role of, here you can see the most important in this whole process is the cloud, then we have the tree, then we have the different type of the like a transport or the road development or the concrete, that also decide about the magnitude of infiltration, the rate of infiltration in this diagram. Here you can see the percolation, and particularly through the capillary fringe, and you can see this how percolate the water through the trees or the vegetation. We have vadose zone, and then we have the zone of saturation, that is the totally flow of the groundwater. And the groundwater also level of groundwater depends upon this zone of saturation. This is a very important process. You can see through this diagram explanation of processes of hydrological cycle. In nutshell, through this diagram you can see starting from precipitation to the groundwater flow. In between you can see this the how evaporation from the tree, then also transpiration process from the tree, evaporation from the earth surface, then through the condensation, precipitation coming, and then after that we have the process of infiltration, then percolation. We have also in groundwater, I would like to tell you this, the one another key words here I would like to identify, that deep percolation. And deep percolation, operates in, saturated soil, So above the groundwater flow, we have the saturated soil where, after that, the deep percolation process operate. Dear viewers, I would like to explain little bit, elaborate this whole phenomena and this whole process, more detail. And as you know, the soil moisture is a very important aspect for country like India, as 68% area may be considered as a dry area, rain-fed area. The soil moisture conservation is a very, very important aspect of hydrological cycle. This soil moisture, helps in variety of human activity for introducing the various livelihood, or diversification of different type of the crops and agriculture. When water is applied at the surface of the soil, 4 moisture zones are formed in the soil, 4 different type of the moisture zones. Generally, it is called the zone 1, that is at the top, a thin layer of saturated zone is created, and such moisture zone is a very important for variety of human activity, including agriculture and plantation. It is followed by zone 2. This is a transition zone. Sometimes also the sustainability of the crops, sustainability of various type of trees, roots, depend on this zone 2. Then we have zone 3, third zone, next layer zone, is the transmission zone, where downward motion of the moisture take place from zone 1, 2 to 3. Last zone may be known as zone 4, is the wetting zone. The soil moisture in this zone will be at or near field capacity, and the moisture content decreases with depth. So the top layer is a very, very helpful for vegetation, but for the deep rooted, tree, I think this zone 4 is also very, very helpful, because the getting the nutrients and energy from this zone. Infiltration capacity rate is also a very complex system. How it depends upon the intensity of rainfall, denoting the different and the maximum rate at which a given soil at a given time can absorb water is defined as a infiltration capacity. So on a particular time and a particular area on a particular soil, how the maximum rate at which the soil absorb the water, that is the infiltration capacity. So the type of soil is also the very important aspects for infiltration capacity of a particular region. So the type of soil. The infiltration capacity of a soil is high at the beginning of a storm and has exponential decay as the time elapses. The infiltration capacity of an area is dependent on the large number of factors like characteristics of soil, condition of the soil surface, current moisture content, type vegetation cover, soil temperature. Last process I would like to discuss with you, that is the runoff process. Most of the water which returns to land flow downhill as a runoff. And so that is why vegetation play a very important role in this. Some of it penetrates and charges groundwater, while the rest as a river flow return to the ocean. Different surface hold different amounts of water and absorbs water at a different rate. As a surface becomes less permeable, an increasing amount of the water remains on the surface, creating a greater potential for flooding. Flooding is very common during winter and early spring because frozen ground has no permeability. So permeability is a very important process, and for the flooding pattern, causing the most rainwater and meltwater to become runoff. Now you can see here in this diagram that how the runoff, soil, vegetation and the moisture capacity, the precipitation pattern, deposition, sublimation, these are the plant canopy, snow, these are the most important component of the whole process. Also through this diagram you can see here the whole process. I would like to divide into these category like a input. Precipitation is a most important input. Then we have the output like a transpiration, evaporation, river discharge, these are the more output. Then the transfers like a stem flow or leaf drip process, infiltration process, surface runoff process, through flow, percolation process, the groundwater base flow, and then the channel flow. These are the transfer process. And then the storage. Storage can be understood like interception, vegetation storage, also some water stored in vegetation, surface storage, soil moisture storage, channel storage, and the groundwater storage. So, the whole hydrological cycle, you can see that of the total 215, almost 12.5% of the total precipitation, percolates as a groundwater, and rest is retained as a soil moisture. Groundwater received, and also this evapotranspiration and loss as evapotranspiration and the transpiration, these are some of the important processes in this the whole. But whole system can be considered as a water balance. A considerable proportion of river flow does not reach the ocean, having evaporated those areas with no natural surface runoff channels. On the other hand, some groundwater bypasses river system altogether and goes directly to the ocean and evaporates. Like you can see here, inventory of water in the earth's surface, that how this the whole ocean, almost 97%, the ocean,
Okay.
ice caps and glacier too.
Sorry to interrupt you, sir. We have a call from Jharkhand.
Yes.
Good afternoon. Please ask your question.
Yes, sir. I have two questions. First one is what are the types of rain gauges that are recording and non-recording types of rain gauges used to measure rainfall? I want to know about the working and its principle. And I didn't understood the Vadose zone and the capillary frame, which he
Some
had
frame you are talking,
an infiltration.
talking about some frame you talk during the lecture. Please you repeat your question.
Yeah, well, I want to know about the rain gauges that are recording type and non-recording type rain gauges, how it works.
Rainwater.
Yeah.
Rain gauge, sir.
Rain
Recording
gauge,
and non-recording type of rain gauge, how this works.
How this work? Rainwater, how this work?
Yes, sir. Rainfall.
Rainfall.
You know, rainfall,
Rain gauge.
rain gauge. Rain
Rain gauge. How this rain gauge works.
Rain gauge, how does it work?
Oh, you know, we have the CWC, Central Water Commission, and the variety of IMD. We have the all network in different part of the India, this rain gauge station, and we collect the rainfall. Even nowadays, we have the automatic weather station also, and many university departments and the many places they can install their own rain gauge station for collecting the, but we have the network all over the country for collecting and measuring this rainfall.
Okay.
We generally measure in the form of millimeter or centimeter. Like you can see this, the soil moisture, atmosphere, streams, rivers.
Okay.
I would like to,
I think we have another question. Okay. Okay, now continue.
I would like to relate this whole process with the climate, and this water cycle, the climate change is very, influencing the whole cycle. Now you can see this, the influence, how the rapidly we have the increase of temperature, and then increase of temperature we have also changes in the rainfall. So the water pattern is also being changed, and so that is why we are getting the two important phenomena. Due to the increase of temperature, you might have seen that the how our Arctic Sea fluctuation, snow melting. In case of India, also in the Himalaya, we get the lot of problem of, snow melting. Gangotri area, you might have seen this. So this can also influence our water availability in the downstreams, like a Indus system, Ganga system, and Brahmaputra system. And so that is why also this global warming can also the sea level rise because of the flooding and other phenomena. Here I would like to this diagram, I would like to tell you that as per forest policy, you might have seen that the forests play a very important role in this the whole hydrological cycle. And the biospheric aspects of the hydrological cycle, you can see here, forest cover influences hydrological cycle. We have the diversity, very diverse type of the vegetation pattern all over the country. As per forest policy, we should have only 33% area under the forest in the plain, but hardly we have 20%. But not 20% also not adequate at forest and tree cover. So that is a very, very important, and it influences deforestation. I would like to bring before you that deforestation can influence our hydrological cycle, but also sometime if you are bringing a new species like eucalyptus in some system, that can also bring changes in the hydrological cycle, because eucalyptus helps in infiltration of the water to the deeper level. And so that is why a controversy emerged that in we should not plant eucalyptus in the dry area particularly, but for marshy area is very, very important. Now you can see here the changing forest and tree cover in India. So our hydrological cycle is very deeply influenced by these, the changes. Then I would like to also.
We have another call from Jharkhand. Good afternoon, friend. Please ask your question.
Yes, sir. Sir, I want to ask that how can we measure the rainfall through rain gas?
Okay. How can we measure the rainfall through rain gauge?
How can
We measure the rainfall through rain gauge.
measure?
Yeah.
Rain gauge is instrument for measuring the
Rainfall of particular locality.
particular locality.
Okay. And then we do average of all the.
Average, we take the measurement,
the method is to measuring the particular
Equipment,
in particular
that is a-
locations.
yeah.
Then how much rainfall does occur in particular location.
particular
And then we do an average, and then we say that this is the national average rainfall.
average
this year and
rainfall
all
for
that.
the whole. These stations are installed already in different
different part
places.
of it.
Different places.
And the location is also identified as per some scientific method, because this place have larger rainfall, this one the lesser rainfall. Accordingly, or anywhere can one install.
Now,
that?
anywhere we can install, but it should be in open place.
Okay.
Open place, and so that the rain.
So there is no kind of survey that this part have this much.
But on that basis, we see that why we have diversity of rainfall.
Okay.
As eastern side, generally we have the more rainfall, and rainfall decreases
Towards western
the western side.
Okay.
But on that basis we
Okay,
decide.
take another question.
But I would like to tell you that
Okay.
these rain gauge stations
Okay.
are even developing country declining,
Okay.
because of we are not able to maintain. So there is one initiative international level, IIH, International Association of Hydrological Cycle, prediction in ungauged
Okay.
basin, prediction like Himalaya.
Okay.
Whole Himalaya, hardly few rain gauge stations are there.
Right.
So through the remote sensing also, is it possible to have some idea about this measurement?
Okay, sorry, sir.
That is the most.
Yeah, we can't continue more because we don't have
Okay.
time now.
Okay.
So, well, friends, with this word we conclude the lecture. I thank all of you for watching the lecture, and on behalf, I thank Dr. R.B. Singh for giving such a wonderful lecture on this great topic. Thank you very much.